Okay, hi everyone. So this is going to be my first video and it's going to be about the basics of SPSS. It's going to be basically two parts and let's start. So first of all, we're going to be talking about the types of the data and we're going to be starting here, types of the data. So we've got two types. We've got qualitative and quantitative. And so what does that mean? When we say we've got qualitative data, it means that it is not exactly in numbers. It is words. So basically when we're saying qualitative, it's basically when we're saying something like gender, or when we're saying something like level of pain, or gender. So it can be divided into two categories. It's either nominal or ordinal. So what do we mean? When we're saying nominal, we mean something that is completely random or unordered. So for example, when it comes to gender, we've got males and females, and none of them are in levels, so you can't say that one is better than the other or one is above the other. However, when we're talking about ordinal, we could be talking about age groups or level of pain, where in reality it is actually ordered. So when you say severe, it is more than mild. And yeah, that's basically what it comes to qualitative. So then we're gonna go to quantitative data. When we say quantitative, it's a number, and that's it, a number. So it has to be something that is continuous. So like age or score in a test or anything that's actually physically in numbers. So when we're talking about SPSS, where we're dealing with the data, usually it is actually all in numbers, even the qualitative. So we basically give each category or each name a number. So when we're talking about gender, in nominals, when we're talking about gender, we can give males 1 or females 2, or the other way around. When we're talking about ordinal, we could give them levels based on their levels. So 1 could be the least and 5 could be the highest, or the other way around. So you can see when you look at it, you will see numbers. However, it's actually categories or names or so on. So that's pretty much it for types of data. We're going to be going over to data analysis, and we're going to be talking about what do you do. So when it comes to data analysis, we're going to be talking about two types: descriptive statistics and inferential statistics. Now, when we're talking about descriptive statistics, we are talking about things that you can describe. So basically, when they give you a specific type of data and be like, describe how it is organized, or how it is scattered, or what it looks like. We're talking about inferential, we're talking about how to compare data to each other. So it's either we're comparing data based on how they are similar or different or significant to each other, or so on, and that will be covered in the next video. So we're going to be focusing on descriptive statistics, which basically means that we are describing our data, or describing how it is distributed. So again, we're going to go back to the types of data, because depending on the type, we have different tests or different ways to handle it. So we're going to start with qualitative. When we're talking about qualitative, again, just a reminder, it's either nominal or ordinal, and it is not a number. So when it's qualitative, since it's not a number, you can't exactly add them to each other to make a mean, right? So what we do is find the frequency of the data. So how many times do we see this? How many times do we see that? Is this more than that, or so on? We can also find the percentages of each of them. I will be showing you an example in a bit. So when we're talking about quantitative, however, these are numbers. As you can see here, they are numbers. So if it's numbers, then we can actually calculate the mean, or so on. So we start by we have two measures of doing this: measures of central tendency and measures of dispersion. When we're talking about measures of central tendency, we mean things that show you where all those data meet, or how the center of these data looks like. So where is it in the center? So what is the mean, what is the average of this, or what is the mode, which is the one that's more common, or where is the median, which is actually the middle. When we're talking about dispersion, it's how varied the data is, so how dispersed, how different it is. So we're looking at the minimum, the maximum and the variance in standard deviation. Okay, so now we're going to look at an example. So the questions would look like something that says that to describe the background characteristics in the sample. And just a heads up, I'm going to be posting a video on what are background characteristics and the difference between them and demographic characteristics later, so check that one out. And okay, so as you can see, we have age, and the age is numerical. As you can see, it's full of numbers. It's made up of numbers. And then we've got the gender, and gender is male and female, and we label them. We label male as 1, we label female as 2. So the data looks like this: 1 2 1 2, like that. So now what we do is, since age is obviously numerical or obviously quantitative, we do the measures of central tendencies and measures of dispersion. So here I just made an example. So we show the mean, mode, and standard deviation. What we do is basically just describe on what those are in your comments. So you say that the mean is whatever number that is, and the mode is this, the standard deviation is that. You can also add the minimum, the maximum, everything else, okay? So when it comes to gender, however, it's a qualitative, and it's in qualitative, it's in nominal, so it has no order. So what we do is basically to show the number of and percentage and frequency. So when it comes to frequency, we know that there's 4 males and 6 females. And when it comes to percentages, it shows that 40% are male, 60% are females. Or in other words, we can also say that females are more than males. So that is basically what you do. Because if you, for example, go and do So for example, if you go ahead and do descriptives or do measures of central tendency for this, you're not going to come up with much, because if your average is 1.5 or 2.5 or 1.8 or something like that, what does that even mean? It means nothing. It has no meaning. So you have to go with frequency. That is pretty much it when we're talking about descriptive statistics. So now we're going to be talking about inferential statistics. And when it comes to inferential statistics, inferential is basically when we're talking about comparing stuff. So we're comparing the data to each other. So we've got either there is a relationship or there is a difference. And in this video, we're going to be talking about the relationships and not the differences. So let's go and talk about the relationships. So when it comes to relationships, again, we have to look at the types of the data. So we've got qualitative and quantitative again. So let's start with the quantitative. When it comes to quantitative, and that, remember, when it comes to relationships, both the two things you're comparing to each other have to be the same type. So it's either both are quantitative, both are qualitative nominal, or both are qualitative ordinal. So if both are quantitative, so they're both numbers, for example, the age and the score on a test, for example. So we're going to be doing Pearson's correlation. So this is the test you're going to do, Pearson's correlation. Now, if it's qualitative and ordinal, so they're both ordered. So for example, severity of pain and age groups, so young, middle-aged, old. And severity of pain, so mild, moderate, or severe. We're going to be doing Spearman's correlation. Okay, Spearman. Both of them have to be the same. And if they're qualitative and they're nominal, so for example, the answers are a yes or no, or their gender, or colors, or anything like that, we're going to be doing chi-square. So I'm going to be showing you again how to interpret them. So when it comes to relationships, we have this very important thing known as the R value. So what does the R value mean? And this is what you do when you have both Spearman's correlation or Pearson's correlation. We look at the R value. The R value has two things you need to take into consideration. First, the sign of the specific number. Is it a positive number or a negative number? And also the actual number. So let's start by talking about the sign of the number. If it's a positive number, that means that the type of correlation or relationship you're talking about is a positive correlation. What positive correlation means is that when one of them increases, the other one also increases. And if the number is a negative number, it is showing that it's a negative correlation. So when one of the numbers increase, the second number decreases. So they're opposite in relationship to each other. Now, when we're talking about numbers, we're going to look at the number, and the R value is usually a number between 0 and 1. It's always between 0 and 1. So if you find a number that's actually above 1, that's wrong. You did something wrong, okay? So look at the numbers. If it's 0, it means there is no correlation at all. If it's between 0.1 and 0.3, we say it's weak. If it's between 0.4 and 0.6, we say it's moderate. 0.7 and 0.9, we could say it's strong. And if it's 1, we could say it's a perfect correlation. Perfect correlation means that it is 100% related to each other. So every single time you increase the first one, the second one increases with a specific value. Okay? So then we're going to have to mix those two together to make our comment. So if it's a positive number that is between 0.4 and 0.6, we can say that it is a positive moderate correlation, or they are positively correlated to each other, and it's in a moderate way. If we have it's between 0.7 and 0.9 and it's a negative number, we say it is a negative, it's a strong negative correlation. If it's a 1, we can say it's a perfect negative correlation or perfect positive correlation, and so on. Hi everyone, and welcome to part 2 on the basics of SPSS. Today I'll be covering the rest of what we didn't cover last time. So that will be inferential statistics when it comes to differences. So let's start. So as we said last time, inferential statistics can be divided into 2, relationships and differences. We already covered relationships, so this time we'll be focusing on the differences. So when it comes to differences, again, you have to divide your data depending on the type. So it's either qualitative or quantitative. First of all, we're going to be talking about the qualitative. And just to note that in qualitative, we don't have to divide them into nominal or ordinal anymore. We just deal with it. So it depends on the number of variables we have available. If we have 1 variable available, we're going to be doing a test of chi, but it's called goodness of fit. So goodness of fit chi-squared. And if it's 2 variables, we're going to be doing crosstabs and chi. An important note to take into consideration is that sometimes we could do crosstabs without chi to show differences. So it depends on the type of question. So if the question is asking for significance, we do crosstabs and chi. But if the question is asking for just the difference without actual significance, then we use only crosstabs and we analyze it manually. Okay, so now we're going to be talking about the quantitative. So when it comes to quantitative, I'm going to start by talking about the 1 sample. So if there is only 1 sample, we do 1 sample t-test. That's very simple, that's it. Now when it comes to 2 samples or 3 or more, there's something you need to take into consideration. So when we talked about relationships last time, we said that both the variables or the samples have to be the exact same type. So either both quantitative or both qualitative. But when it comes to differences, that's not the case. When it comes to differences, only one of them has to be quantitative. So as I said, when it comes to quantitative indifferences, both of them don't have to be the same type. So how do we tell which one is the one that's quantitative and which one is the one that could be qualitative? So when it comes to data, there's something you should keep in mind is that there is something known as the dependent variable and something known as the independent variable. Dependent variables are ones that depend on the other. So that means it changes depending on what the other one is. So for example, if we say that how the hours you study affect the amount of grades you score, then the hours you study are the independent variable and how much you score is dependent. So in other words, if you change the amount of hours you study, you are most likely to change the score or the grades. However, if you do change the grades just like that, you don't exactly change the number of hours you studied because it already happened or it's already independent. Does that make sense? So the dependent variable has to be the quantitative one because it's the one we're analyzing. We're analyzing how the independent affects the dependent. So what you need to analyze, or what you need to focus on, is the dependent variable, which is supposed to be quantitative. So now we're back to our topic on differences, and we've already covered the one sample, so we'll be focusing on the two sample right now. So with the two sample, first you need to decide whether the data is paired or non-paired. So if it's paired or independent. What paired means is that basically it's the exact same variable, however it's before an event and after an event. So for example, if we're doing our research on weights of individuals, it'll be the weight of the people before a diet and the weight of the same people after a diet. So it's the same thing, it's still weight, but it is after or before an event. And in that case, we will be doing something known as a paired sample t-test. Now, if it's independent or non-paired, it means that there are two completely different things. So maybe we'll be comparing the weight in males to the weight in females. And so they're two different people. And in this situation, we'll be doing independent sample t-test. So I'll be giving you examples in a bit, so after we explain those. Now we're going to be going to the 3 or more samples, and just to be clear, when it comes to 3 or more samples, we're not talking about 3 different variables. So we're not going to be comparing 3 separate things to each other. We're still comparing 2 things to each other. However, in one of the 2 things, we have 3 or more categories. So let's go back a bit to the independent. For example, in the independent, we could be comparing the weight, as I said, to the gender, female or male. Gender in this situation has two categories. It's either male or female. So we do the independent non-paired test. Now, if we were doing the exact same study, but instead of on gender, on age. So we've got the weight compared to age. If we're comparing the weight to the age and we're dividing age into different groups or categories, for example, young, middle-aged, old, very old, or something like that, then when it comes to the qualitative variable, or the variable that we are using as that's in groups, has more than three or more samples, then we're going to be doing one-way ANOVA. Again, just to be clear, it's not the amount of variables, it's just that in one of the variables, the one that's independent, the one that's grouped, there are 3 or more categories. So now I'm going to be covering examples. I'm going to be showing you 3 examples, each for the last three tests we just talked about. So independent, paired, and ANOVA. So I'll read the first one. It says that, is there a significant difference between score and test before adding revisions and score and test after adding revisions? So let's focus on here. What is the variable we're looking for here? It's a score and a test. And what's the variable we're looking for here? It's also a score and a test. So what's the difference? The difference is that in the first part, it was before we added revisions. In the second part, it's after we added revisions. So what's the difference? The difference is that in the first one, it was before we added the revisions. In the second one, it was after we added the revisions. So what does that mean? It means that it's the same variable in different conditions. So that means it's a paired sample. Let's go to the second one. We have the question saying, is there a significant difference between score and gender in the data? So the score is a number or mark, and the gender is either male or female. So that means we have two samples in the gender variable, and the score is the one that's quantitative, or the one that is dependent. So that means we're going to be doing an independent sample t-test because it's an independent sample. Now we can go to the third one and look at it. It's asking if there is a significant difference between test scores and age group. And in this situation, age group is divided into young, middle-aged, and old. And since this has 3 categories, it means that we're going to be doing, it means that we have a 3 or more sample, so we're going to be doing ANOVA. Now we're going to be quickly talking about the difference between parametric and non-parametric tests. So when it comes to those t-tests, there's 2 types. One part is known as parametric and the other part is known as non-parametric. And you have to first, before you start, you have to decide which one your data is so that you're able to know which test to use. So what does parametric mean? So first of all, you have to take your quantitative data, only the quantitative one, or the dependent one, and make a histogram out of it. And then you look at the histogram. If the histogram looks like something like this, or in other words, it has a bell-shaped curve, so we can say it's normally distributed. It also has to be roughly symmetrical, so that means that the highest point is kind of in the center and both sides look similar or the same. The other type of graph is non-parametric, and that one has no specific pattern, or it is skewed to one direction. So the curve looks skewed to a direction, or it's not normally distributed. It's not symmetrical, and it doesn't have a specific pattern. So what do we understand when we say it's parametric or non-parametric? When it comes to parametric, we do the tests we learned earlier. So if it's a paired t-test or an independent t-test or a one-way ANOVA or one sample t-test. However, when it's non-parametric, the tests have different names. For one sample t-test, it's just a one sample again, so it's no problem. But for the other ones, they have other different names. The name in brackets is the name of where you find the test, and the name below it is the actual name of the test. So you'll find the test in related samples, and then you'll tick on the Wilcoxon test, okay? Or you'll find it in independent samples, and you'll pick the Mann-Whitney-U test, or the Crooks-Hall-Wallace test, which is found in the K independent samples. So basically, the only difference is that the type of test changes from one to another. So thank you very much for watching. I'm going to be posting the pictures that I used while explaining, and make sure to tell me what you think about this. I would love feedback, and thank you. Bye.